Okay guys, let's start the session then. In this session we're going to discuss about processing performance improvement techniques. Okay, whenever you give interviews on MSBI, mainly particularly on SSAS, they'll stress a lot on performance. Like did you get chance to work on performance tuning, and if yes, what are all the techniques you have applied and so on. One of the first and foremost thing that you have to answer whenever you get a question like this is about partitioning of the fact tables, and you are very well aware of that, what is the different techniques and what are the benefits you are going to get with that. Now inside SSAs, what's happening and how can you improve the performance? I mean, queue processing, if the queue processing is taking 2 hours, how can you reduce it by half an hour or so? So let's see some of the techniques which helps in improving the queue processing time performance and also query time performance. Before going to that, let's see what's happening inside the queue. That is very important one to know. Why? Because if you know what's happening inside the queue, then you can take right decisions, like right techniques to implement performance improving techniques. Okay, let's say I have a cube with only one dimension and one fact table. Let's say this is my dimension table: employee ID, name, designation, department, and let's say city, state, country. I have some information. I don't worry about the information. Okay. Let's say I have some data in this and I have one fact table. Fact table is leave ID from to number of days, it's a number of days, and then applied by is approved by. Okay, let's say I'm running a pretty big software company where I have 1 lakh employees. So what will happen? This table will have 1 lakh records. Agree? That means employee details of each and every employee. Let's say employee, let me write at least one employee, Desig, IT, city, let's say bank, state Karnataka, country India. Like this I'll have all the details of 1 lakh employees. So on an average, let's say each guy has taken 10 days leave. So how many records will be here? In this table I'll have something 1 lakh into 10, that is 10 lakh records in this table. Let me write one sample. From is December 15, 2012 to December 16, 2012. Number of days is 2. Applied by is employee ID 1, that is Rupesh. Approved, yes, approved by, let's say, employee ID 2, who is my manager. So in this fashion, you will have data in this table. This is, let's say, in this case, this is your fact table or measure group table, and this is your dimension table. Now, as part of queue processing, what's happening? So many things will happen. One is it reads the data. Next thing, it will create aggregations, and the third thing, it will create indexes. Mainly these three things will happen when the queue is processing. Reading the data, what it will do as part of reading the data. Let's say this is your cube memory. I've taken some memory here, I mean some space. Let's assume this is your cube memory. Okay. When you say process the cube with dimension employee and fact table leave details, first it will take the appropriate data into this table from here. Appropriate data in the sense, I have, let's say I have only 4 attributes. One is name, another one is designation, another one is department, and fourth one is city. So if I have only these 4, it will take only these 4 into the SSAS memory, and then it will read the appropriate data from this fact table. So after finishing this job, after finishing the reading of data from the source, The next job is creating aggregations. How it will create aggregations. This is very important. Aggregations it will create based on this one first. It will go employee ID. It will join with this applied by. We will give this relationship in dimension usage, where we define the relationship between the dimensions and the measure groups. So this column will be joined with this, and it will take the aggregations of the first one first. Name wise, number of days. It will store in one table. Next, designation wise, number of days it will store in another one. Department wise, and then city wise. And these will have some relationships, everything will be set. So this is how, once the data is aggregations are created, then it will work on indexing part. So this is how the data will be read based on the key columns that are present in the dimension table and the fact table. So this is the job. Read the data, create aggregations, and then create indexes. Aggregations. For what all attributes it will create aggregations? That is important to know. Let me show you an example from what we have created now. If you see, this is the cube I created. For example, if time is processing, time dimension is processing, what it will take is, it will take this attribute. First, it will take the distinct values and read the data into analysis services. It will keep the distinct values. In the same way, it will read the distinct values of each attribute. In other words, each column from the table dim time. And in the cube, it will take the measure group. This time has relationship with fact internet sales on three bases. One is due date, another one is ship date, and third one is order date. So it will join the table with all the three combinations, and it will take the group by statement of each attribute present in the time dimension with each measure that is present in the fact internet sales. So a simple example is, select what is the columns that are present I have selected in this fact internet sales. Let me see that I have so many. So for example, I'm showing you an example. I'm not going to show everything. It is going to take, it is time taking task. So select tax sum of tax amount, comma, sum of, what is the other one, sales amount, comma, and so on, comma. First it will take one attribute. So first it will take one attribute, calendar year, from fact internet sales, join, inner join. So join with dim time on some condition, group by calendar year. So this is for one attribute. So this is the attribute of the time dimension calendar year, and this is the measures that are present in the fact table. So it will take the sum of each measure that is selected in the fact table. Like you can see, all these are fact table measures. Okay, and calendar year is one attribute from the dimension table time, and it will join these two, group by calendar year. Next time what it will do, it will group by calendar quarter, and then calendar month, and then calendar semester. So for each and every attribute, it will create aggregations for each and every measure that is available in the fact internet sales, and these aggregations will be created based on the relationship whatever we have given here. Okay, this is what happening inside. So the problem, where the problem will come is, let's say if you take the time dimension, when the calendar quarter is processing, or calendar semester is processing, or calendar year is processing, the problem is, for example, to know the months, let me open SQL Server Management Studio to explain the problem here in a better and clear way. So I'm gonna execute the same, whatever I have taken here. I don't need this stuff. Let me delete it. And I don't want physical stuff also. Let me delete it. And I don't want week number. So I have only calendar year, semester and quarter. In the same way, from the measures, I don't want all the sheet here. So let me remove everything except sales amount and tax amount. So I need these two. I'm removing all the stuff. Now, by considering the same example, whatever we have there, let's see how it executes. You can clearly see here I have two measures, and in the dimensions part I have only 4 attributes. Okay, and the joining one is, which one is joining these two? Key column, that is dim time, time key to ship date key. In this case it is due date key, and the third case it is order date key. It is joining with 3 different combinations. Now let's take any one combination. Here I'm going to take the combination of ship date. How this time in bracket ship date is going to create aggregations for fact internet sales. And then we will see how due date is going to create aggregations for this. And then we're going to see how order date time key is going to create aggregations for this. So for creating this, first let me go to AdventureWorks DW. What are the measures we have? We have sales amount and tax amount. You can see it here. And what is the aggregate function we have defined for sales amount? It is sum. And what is the tax amount? It is again sum. So the query will be formed like this. Select sum of sales amount, comma, sum of tax amount from fact internet sales. So this is the highest level of aggregation. It will give top level of sales amount of total sales amount and total tax amount. Now we are going to do this for attribute English month name. How the aggregations will be created for English month name based on the ship date key. The first one we are going to see now. So it is going to join with a dim time on dim time dot time key is equal to fact internet sales dot ship date key. Now the relationship is set, and we are going to see the data based on English month name. That is our requirement. So what we have to do now? This should be part of here. So we want to see English month wise. So I'm taking English month name here. English month name, and the same column I have to add in the group by statement. Why? Because this is the only non-aggregating column present in the select list. So group by English month name. If I execute this, you can see month wise sales, that is sales amount and the tax amount. This is one aggregation. This aggregation will be stored in your analysis services server. Okay. Now how to do for quarters? So for doing the same for quarters, you simply change it to calendar quarter and copy the same here, right? You can see the quarter level information is also coming after aggregating. And the third one is semesters, and the fourth one is years. So let me have everything here. Calendar semester, group by calendar semester. Now here calendar year, group by calendar year. So these 4 queries will fulfill my requirement of creating the aggregations for these two measures that is present in the fact internet sales measure group for all the 4 attributes that I have taken here. If I have more attributes, the number of queries that will come here will be increased. This is fine for ship date key. How to create if it is for due date key? That is for new dimension relationship. So the ship date key will become due date key. In the same way, you can do for the other one, that is order date key. So do we need all these queries? All these queries will be executed as part of your queue processing. As part of the queue processing, if your queue design is similar to what I have done. If you have more attributes here, more such queries will come into picture, like one for physical year, another for physical quarter, another for physical semester. Like this, you'll be getting more and more queries to create aggregations. Now, I have a question here for you guys. So this one, the first query is giving me month-wise sales, right? Which month, what is the sales, and so on. And for the second quarter, if you see, I'm again joining with due date key and then aggregating the data. If I have 100 crores of records in my fact table, let's say in this table, so what will happen? This 100 crore records in this table will be joined with 600 or 700 records that is present in the time, and then it will create the aggregation part, right? And in the same way, again 100 crore records will be joined here also, and again 100 crore records will be joined here. So all the 4 cases, if you see, in every case the 100 crore records will be, that is present in the fact table, will be joining with the dimension table, that is dim time table, based on this due date, and then it will create either month, quarter, semester, and year. So my question is, if I get all the months information here, and you know this data is hierarchical, year, quarter, year, semester, quarter, and month, by joining 3 months, like January, February, and March, can't I get quarter information? Is it possible or not? If I tell you the sales for January is $100, sales for February is $200, and sales for March is $300, if I ask you what is the sales for first quarter, can't you answer it as $600? 100 plus 200 plus 300. Can't you do in this way, or you have to go through all the transaction records that is present to get that information? That is not required actually. You can get the information based on the months you have. In the same way, if you have quarters information, can't you get the information for semesters? Like if I have 2 quarters information, you can easily get semester information. If you have 2 semesters information, you can easily get year information. And let's say there are 100 crore records per annum, and like that you have 10 years information. Okay, let me take Excel, 100 crores, and you have per annum, and you have 10 years information. The total fact records will be 1000 crore records, right? So for processing months, you have to go through all 1000 crore records, right? Now for processing quarters, instead of going through 1000 crore records, already you will have that information of months. How many months? 12 months per year and 10 years. 10 into 12, that is 120 records will be available if you group by the statement month-wise, similar to this. If you group by, you will get very less information, like 120 records. Each year, 12 months, like that, 10 years. So using these 120 records, you can get this information. And for semesters, it will be 4 quarters per month into 10 months. Sorry, I'll write it here. 4 quarters per annum into 10 years, it will be 40 records. You can get the semester information with 40 records, that is the quarter information. So for years, it will be just 20 records. So using these by taking the help of already processed information, you can avoid processing 1000 crore records here, 1000 crore records here, and 1000 crore records here. You can imagine how much time it is going to reduce. Is it going to reduce the time, or it is more expensive? What is your call on this? Which way is better? Going through 1000 records, 1000 crore records, all the cases, or going with by taking the help of already aggregated data? So this case, obviously it reduces time like anything. The first case, it will take time. Second case, third case, and fourth cases, it will be reduced drastically. If this count is increased to 1 lakh crores or something like this, but this will remain the same, right? But here, if this is 1 lakh crores, the same here, the same here, the same here. So you can achieve this part. You can achieve this one by using hierarchies in dimensions. This is the major use of hierarchies. If you define the hierarchies properly, then you can play like anything. The time will be reduced like anything. Okay. So guys, hierarchies are very, very friendly creatures for us. It helps us a lot. Okay. So whenever it is possible, create hierarchies. This is only one use of hierarchies. There are another uses. When you are learning MDX, you will come to know about the major advantages, other advantages of using creating hierarchies in SSAS. But this advantage is the best one, and even the second one, it's awesome advantage. You will come to know. You will come to know when we discuss about MDX concepts. Now, this is fine. First, this one will go to the root level. We call it as root level. Okay, key level joining, right? This is called as root level. It will go to the root level, execute, and get the month's information, and this quarters will take the month's information. You have to specify this. What you have to specify here? Quarters is dependent on months, and semesters is dependent on quarters. Years is dependent on semesters. You have to specify this information. Where you can specify this information? You can specify this information in the dimension attribute relationship page. It was not like this in SQL Server 2005 version. There was no such separate tab for attribute relationship. This is added only from 2008 onwards, and this is a beautiful one. You can make use of this. I mean, earlier it was hectic. Giving relationships was hectic. Now it's a pretty easy. Now it's easy for me to explain what this box is. This box is for processing this information. It will join the table with this key. For processing this information, it will join the fact table with this key. For processing this information, it will join the table with this key, and in the same way, this one with this key. As I told you here, everything it will go to the root level. By default, it will be like this. Now, let's create hierarchies and define these kind of relationship. How to do that? First, for that, we have to define the hierarchy. The first and foremost thing you have to do is defining the hierarchy. So first one is calendar year, next one is semester, next one is quarter, and the fourth one is month. So if you define the hierarchy, it won't execute data like this. It won't process the data in this fashion. It will process in the same way, the earlier case, this way only. Why? Because the attributes are not related. Still, this is dependent on time key. This is dependent on time key, and this is also dependent on time key, and this is also dependent on time key. Okay, let me process in this fashion and see. Let me process this dimension alone. So the dimension is processing. Okay, this is fine. If you process the cube, it is going to take some time. Why? Because everything is dependent on time key. In this particular example, it won't take much time. Why? Because my fact table is not having much data in it. For example, if you see my fact table, to see the number of rows, it is just 60,000. 60,000 is nothing for SSAS. It can be processed in a second, in less than a second. So when the data size is increasing, let's say this data is not 60,000, let's say this data is something around 500 crores, then the performance impact, will be on the processing speed. So always remember, after creating hierarchy, if this warning message is there, that means the attribute relationships are not set. It is still, you created the hierarchy guy, but this is still dependent on the key column. Here you have to define the hierarchies. Generally, what people will do is whenever they find this warning message, they will keep the mouse on and they'll read this. Attribute relationship do not exist between one or more levels. Okay, fine. Attribute relationships are not there. So they will come here and they will give the attribute relationship. How to give the relationship? This guy data, month data is dependent on this guy, right? For getting the month information, it has to join with time key. But this can roll up and give me quarters. So select this. Observe this one carefully. I selected this and the select is still on and I'm dragging it onto quarters. That means month will roll up. Roll up means sum and give the aggregated value. That is called roll up to quarters. And these quarters will roll up to semesters. And these semesters will roll up to years. And if you see, for getting the month information, I'm dependent on time key. For getting quarters, I don't go back to time key. I'll just get it from English month name. And for semesters, this one, and years based on semesters. So first this one has to be executed, and then this one has to be executed, and then this one, and then finally the calendar year. So people, when they see that attribute relationships are missing, they will come here, they will fix that, and you can see the warning message is gone. Now they think everything is set and they can process the cube. Let me process the cube, and for our surprise, it may throw error. Okay. So it is creating some nonsense. Let me do some quick fix here. You don't need to worry about this. You won't face all these problems whenever you are working on projects. So let me delete this stuff. Let me process it. Errors in metadata manager, either the database with the ID does not exist or the user does not have permissions. Okay, fine. This is completely gone. Actually, I've done. This is mainly due to some mismatch in the IDs and all. So what I can do here is I can create a new solution. That's the easiest way. Let me create a new solution. So that solution is gone. So what I'm going to do here is a new quick solution. So I'll take it as again MSBI. And I'm going to show you this is not going to take more time. You can create some hundreds of cubes in a day, man. So whenever I give you an assignment, you are taking a lot of time. Maybe you have your personal problems. But what I'm trying to show here is it is not going to take more time than a few hours to create 10 to 15 cubes. So I've taken internet sales, added related tables. I don't want this. I don't want this. I don't want this. I don't want this. I'm going to work on current time now, most of the sake. So I'll take time. So I'll create the time dimension. And I'll take only the measures that I want. One is calendar quarter, English month name, calendar year and semester. So let me remove this. Finish, the dimension is created. Now let me create the empty cube. Finish. I'll take new measure rather than measure group. From fact internet sales, I'm taking sales amount and I'm taking tax amount. And here I'm taking the cube dimension dim time. As it has created 3 aliases, this is fine. Now my next job is creating the hierarchy where we were. We were at the point of creating the hierarchy and processing it, right? Now you can see the relationship error is here. So how to give the relationship? Month will roll up to quarters, quarters will roll up to semesters, and semesters will roll up to years. And you can see this is gone now. Now if I process this, again, as per my experience, I'm saying it will throw error while processing the dimension. You can see here. It is saying a duplicate key has been found when processing dim timetable semester is 2. It is saying I found an error, I found a duplicate value, and it is saying the key is 2 for the semester. If you want to see the error properly, you can select that and go to view details. Calendar semester, the value is 2. But when I start explaining about dimensions, I told you clearly only this time key or the key column should not have duplicates. I said the remaining things can have duplicates. But why this is coming into picture now? If the time key is not having duplicates, I'm pretty sure about this. Why this new error is coming into picture? So this is because we created hierarchy. So when we created hierarchy, I'm telling the server that based on the months you can get the quarters, and based on the quarters you can get the semesters, based on semesters you can get the years. But if you see the timetable here, dim time, and if you take the quarters or semesters, yeah, this is fine. You can see semester 2 for 2001. There are so many records like this, and 1 for 2002. And again, after this one, you are gonna get only 2 for 2002, right? The data will be like this. 2001 semester 1, 2001 semester 2, 2002 semester 1 again, 2002 semester 2. Like that the data will be repeated. Now what it is saying is, you said this 2 is present for 2001, but again I got 2 for a different year. So which one you want me to take? Which one is correct? It is saying there is no uniqueness between these columns. So if I have data like this, 2001 1, 2001 2, 2002 1, 2002 2. That means 2001 year first semester, 2001 year second semester, 2002 year first semester, and 2002 year second semester. It will be easy for the server to identify. Instead of that, if the data is semesters is like this, while processing these semesters, it will find out, I have duplicates, man, which one I have to take. You are saying the data is hierarchical in nature. Hierarchical in nature means, if you are aware of the hierarchy, how it looks. Hierarchy looks like this. Let's say that is year and this is semesters. Okay. And under the semesters, let's say I have quarters. Like this, you will have different years, right? Yeah, parent and child. Okay. Like this, you have different years, right? And this guy will have his own semesters. And this guy will have his own semesters, right? But this semester should not be here repeated. This semester should not be repeated. That is what it is saying. You said this data is hierarchical in nature, this column and this column, but I'm getting duplicate data for same different years. How to solve this? How I can identify which semester belongs to which year? It is saying I don't have uniqueness here. So what we have to do? We have to provide uniqueness in this case. If you can provide uniqueness, then we are well and good. How to provide uniqueness for each attribute? Let me show you how to do that. Before going to that, before providing the uniqueness to the data, I have to explain you about two columns. One is key column and another one is name column. Okay. What is key column? Key column is the one which is used to query the data or join the data. Name column is the one which is used to show the data. I'll demonstrate a simple example here. For that, I don't need to have these relationships here. Let me demonstrate that key column and name column example. Then we can go to the how to fix these kind of issues. So for demonstrating the same, I'm taking a new dimension and for product table. And here key column is product key and name column is also product key. And I have taken English product name as another one more attribute, and I clicked on finish of the dimension creation. Now if I process this, process successfully, and you can see, go to the properties of this key column. At the end you can see key column is product key and the name column is nothing and value column is nothing. If the key column is product key, if the key column is selected and the name column is not selected, that means it will take the key column as name column. Remember this point, this is very important. If the key column is selected and the name column is not selected, then what is name column means? Nothing but what is key column. So if I go to the browser and see the product key, you will have only the keys that is showing, and also for querying purpose it is going to use the same keys. And now go back and see what is the name column and key column for English product name. Here you can see the key column is English product name and name column is not selected, nothing is selected. So the name column is also the English product name, and if you see the browser, you can see it is showing English product names. Now to get more clear picture about this key column and name column, what I'm going to do is I'm going to take this product key, I'm going to keep this key column as is, and I'm going to change this name column as English product name. Okay, for the product key I've changed the name column from none to key column, English product name. If I process the cube now, if I process the dimension now, it is successful. And let me go to the browser and let me reconnect it first before going to the next step. If I select the key column, product key, it is not showing the keys now. It is showing the English product names. And if I select the other one, it's again the same English product names. Right? You can see the English product name is showing instead of key. That is because I selected the key column as English product name. Name column. Key column is the one which stays in backside. I mean behind part, not into the visibility. It won't be shown to any user, and it will be used for querying and for all those stuff. And this name column, this is used for displaying purpose, displaying to the user. If I select name column, it is showing names instead of keys. Why? Because keys is just behind part. Right? It won't be shown. It is shadow part. Okay. So the important points to remember here is, if you don't specify anything for the name column, that means it will take whatever is given in the key column. And the next thing, you can give two different things, one for name column and one for key column, and the name column will be shown to the users, whereas key column is used to query the data. And the third point is, if I have more than one, you can have n number of keys. if I have more than one in key column, in this case, that is, in this case, the name column is mandatory. I'll show an example here. Now I have one key column here. So with this key column, I'm taking color also as key column. I have two key columns, which is acting composite primary key. We call it as two columns as one key. I have these two columns as product, English product name key. So in this case, the name column should not be null. If it is null, it will throw error saying this. The name column should be defined because there are multiple key columns. Why? Because if it is only one key column, it is taking the same key column, right? Now I have two, which one to show? Even SSIS doesn't know which one to show. So what it is saying is, you select what is the key column you want to show. If I select color, instead of English product name, it will show color. If I select something else, it will show that one. So name column is for display purpose, whereas key column is for query purpose. And the second thing, name column can be empty if you have only one key column. And if you have more than one key column, name column is mandatory. So these are the three key things you have to remember. So having this knowledge, we can proceed for the fix of the issue. Let me delete this stuff first. I've deleted the dim product. I don't want that sheet. Now, this one has, let's see what is the key column and name column. Sorry. The key column is calendar year, and name column is nothing. This is fine. Why? Because year will not be duplicated. It is not rolling up. So no issues, nothing to change here. So the next thing where the problem is coming is semester. Semester key column is calendar semester. So it will be 1, 2, 1, 2, 1, 2, 1, 2 for 4 years. So here we have to provide uniqueness. So for providing uniqueness, if I select calendar year, scroll to this up. So what this one will become is 2001, 1, 2001, 2, then 2002, 1, just like I have shown here. In Excel, I have shown you, right? Like this it will become. Now the key column is combination of 2001 from year and 01 from semester. 2001 from year, 02 from semester. So like this it will become a unique key. Now I have two columns selected. So what is the next step I have to do? I have to select a name column. Why? Because it will become a mandatory one when you have more than one key column selected. So what you want to show for this attribute? This is calendar semester. So query based on year and semester, but display only semester. So I have selected semester. Now if I process this, that error should not come. Whatever the error we faced, that should not come. And we can expect the next level error. And if you go here and view details, you can see that calendar quarter is having the same problem now. The problem for calendar quarter is, it is 1, 2, and you'll have 2 more records like this, right? 3, 4, and again 1, 2, 3, 4. Here again the uniqueness problem. How to provide uniqueness? 2001, 1, 2001, 2, 2001, 3, 2001, 4. This is how you can provide uniqueness. 2002, 2, 2003, 2, 3, 2002, 4. So this is how you can provide uniqueness. For doing the same, what you have to do? You have to go for the calendar quarter properties and select it and provide calendar year plus calendar quarter as the key column, and obviously you have to provide the name column, which you can take as calendar quarter. So in the same way, you have to go for months. Why? Because months are rolling up to quarters, right? So make it as year. Some kind of uniqueness. It is not always year. You can go for semester and month. Somehow the uniqueness should be provided. Why we won't go for semesters here? If you give for semester 1, quarter 1, semester 1, quarter 2, semester 1, quarter 3, semester 2, quarter 3. it will come like this. Again for 2002 it will be 1 2 1 1 2. I confused 2 3 2 4. It will be same will be repeated. The only way you can provide uniqueness is by taking the highest level one, that is year. Okay. So calendar year and English month name is selected. What is the key column? Sorry, name column we have to give. It is English month name. What we want to show the users, end users. So now I set everything. Now let me process it. It should process successfully. Why? Because there is no duplicate information. Everything is fine. Now if you process the cube, it will get processed and you can play with the data by using the hierarchies. So this is how you can create hierarchies, the first step, and what is the key column and the name column, and how to provide attribute relationship. While providing attribute relationship, you have to be careful. Why? Because you should provide uniqueness, and the way I explained you is the best way to provide uniqueness. Okay. This is very tricky one, so I suggest I'm going to put an end to the session here. So I suggest you guys to go through this video, what I'm going to share, and practice it couple of times. Not only on years, try different hierarchies and try to practice it, and try to give attribute relationships, define hierarchies, and try to process the cube and make it successful one. So if it is successful, then you are good. So try to practice couple of data, different types of hierarchical data, and come fresh with the complete knowledge on creating the hierarchies. Why? This is very important one as far as performance is concerned. So you can easily understand what is the performance gain you can expect. See, this is how it is going to be processed. So the performance gain will be very huge. So try to practice a lot on this part. Why? Because this will be used. You will be using this very frequently whenever the performance hits your project. Thank you and bye bye.